How does your Cosmos app actually talk to consensus and decide what goes into a block? In this module, we'll unpack that bridge, what classic ABCI does, why it's limiting, and how ABCI++ unlocks smarter block building and validation. To navigate the Cosmos stack, keep a clean mental split between consensus and application. CometBFT is your engine for networking and agreement. It gossips blocks, runs the voting protocol, and decides which block is final. The application handles business logic, state transitions, modules, and how transactions actually change data. ABCI sits in the middle as the contract between these two worlds, so you can evolve consensus or application independently, and even write the app in a different language. ABCI is the structured protocol bridge between CometBFT and your application. CometBFT owns consensus and block production, and it initiates everything by sending well-defined requests. Your app behaves as a pure state machine. It never drives consensus. It just deterministically answers those requests. That separation is powerful. You can rewrite or upgrade app logic, even in another language, without touching the consensus engine, as long as you keep speaking the same ABCI protocol. In the classic ABCI model, block execution is intentionally linear and predictable. Init chain runs once at genesis to establish initial state and configuration. After that, every block follows the same strict sequence. Begin block runs block-wide logic, things like slashing, fee distribution, or reacting to evidence from consensus. Deliver text is called repeatedly, once per transaction, applying each one deterministically to state. This is where most business logic lives. End block then wraps up the block by updating validator sets or other finalization tasks. Finally, commit persists the new state and returns the app hash that consensus will agree on. In this classic setup, the application is basically a passive receiver. Blocks are proposed by the consensus engine, and your app only gets to validate after the proposal is already assembled. That means you can't really shape mempool behavior, prioritize certain transactions, or enforce application-aware block construction. You're also blind when it comes to attaching custom data to votes for things like fraud proofs or extra checks. ABCI++ was designed specifically to break out of this passive role. ABCI++ represents a proactive paradigm shift in how Cosmos chains are built. Under the classic model, consensus produces blocks and the application mostly reacts to whatever is proposed. With ABCI++, the application steps into the loop. It helps shape what goes into a block and can even influence how proposals are evaluated. So instead of a passive endpoint, your app becomes an active collaborator in block creation and validation. ABCI++ effectively moves block building logic into your application. Rather than CometBFT blindly packaging mempool transactions, your app now curates them. In Prepare Proposal, the app sees a candidate set of transactions and can reorder, filter, or inject its own. This is where you implement custom priorities, fee markets, or block size policies, all with full access to state via an isolated sandbox. Process Proposal then lets every validator reevaluate that proposed block. They can sanity check application rules, enforce additional constraints, and either accept or reject it before voting. Together, these hooks turn block construction into deterministic application code you fully control. ABCI++ doesn't just let the application build blocks. It also lets it augment consensus with extra data attached to votes. Extend vote is where each validator can attach application-defined metadata to its vote, things like state commitments, data availability hints, or fraud detection signals. Verify vote extension runs on the receiving side. Your app decides whether those extensions are well-formed, trustworthy, and consistent with your policy before the votes are accepted by consensus. With ABCI++, you're no longer a passive consumer of whatever the mempool hands you. You actively decide which transactions enter the block, in what order, and under what conditions. You can prioritize by gas price, by message type, or by entirely custom business rules. You can enforce that certain transactions appear together or never together. And you can immediately reject malformed, off-protocol, or clearly malicious proposals. ABCI++ essentially lets you turn block production into a policy engine for your chain's economics. Instead of accepting whatever the default mempool and proposer rules give you, you can encode your own priorities. You might maximize fee revenue, minimize latency, or enforce fairness between user classes. You can hard prefer governance, oracle, or liquidation transactions, or throttle spammy types. Think of prepare proposal and process proposal as dials that let you shape how economic value flows through your chain. Vote extensions effectively turn a yes or no vote into a rich security message. Validators can attach cryptographic fraud proofs so that when something looks wrong, they broadcast exactly why. They can also include data availability commitments, helping light clients trust the chain without downloading everything. And because the application validates these extensions, it can detect misbehavior quickly and respond with slashing, alerts, or even halting the chain if needed. Classic ABCI treats your application as a pure executor. CometBFT hands you finalized blocks, you run deliver to Rex and friends, and you mostly accept whatever the mempool and proposer decided. You can validate and enforce invariants, but you don't really influence which transactions get in or how they're ordered. ABCI++ changes that relationship. With prepare proposal and process proposal, your app participates in block construction itself, enforcing policy at proposal time. With vote extensions, validators can attach additional application-defined data to votes, letting you add extra security checks, signaling, or commitments directly into the consensus flow. You've now seen how ABCI++ pulls consensus right up next to your business logic. The real question becomes, what would you build if block structure, token economics, and cross-chain flows were all under your control? In the next modules, we'll turn that control into concrete designs and production-grade implementations.